In 2019, Miami launched an ambitious plan to transform the city with a striking new bridge over Interstate 395. 6 soaring concrete arches were meant to reshape the skyline, reconnect divided neighborhoods, and finally ease one of South Florida's worst traffic bottlenecks. The promise was clear: a 5-year build and a manageable budget. 5 years later, that promise unraveled. By 2024, only 2 arches stood complete. The opening date slipped to 2029, and cost ballooned to $866 million, turning a symbol of renewal into one of Florida's most complex and expensive bridge projects. What began as a bold vision became a cautionary tale of ambition, colliding with political pressure, engineering risk, and unforgiving ground beneath Miami. A highway built for a smaller Miami. The roots of the problem go back more than half a century. When Interstate 395 opened in 1971, Miami was a very different city. The elevated highway was designed as a short but critical connector between downtown, Miami Beach, and the Port of Miami. At just over a mile long, it carried 2 lanes in each direction. Adequate at the time, but barely. Growth came fast. Tourism surged, the port expanded, downtown densified. Within a decade, I-395 was already straining under traffic levels it was never designed to handle. By the 1990s, congestion had become routine. By the 2020s, more than 450,000 vehicles a day were funneling through the Midtown interchange, creating daily gridlock and frequent delays that rippled across the city. The highway's physical presence also left deep social scars. Elevated concrete structures cut directly through Overtown, isolating communities and reinforcing decades of urban division. What began as an infrastructure solution slowly became both a transportation failure and a symbol of past planning mistakes. Choosing a landmark instead of a simple fix, by the early 2000s, the condition of I-395 could no longer be ignored. The roadway was aging, structurally stressed, and economically harmful. In 2010, the Florida Department of Transportation announced plans for a full reconstruction. Florida Department of Transportation could have taken the straightforward path: widen the highway, replace worn-out structures, and move on. That approach would have been cheaper, faster, and far less risky. Instead, officials aimed higher. The project was reframed as an opportunity not just to fix traffic, but to reshape Miami's image. In 2015, designers were brought in to imagine something iconic, an infrastructure project that doubled as public art. The result was a cable-stayed bridge unlike anything else in Florida: 6 soaring arches rising from a single central pier, inspired by flowing water and Miami's coastal identity. It was a stunning concept. It was also an engineering nightmare waiting to happen. Why 6 arches changed everything. Most cable-stayed bridges rely on 1 or 2 towers. Miami's design chose 6, each with a different height, curvature, and structural role. The decision wasn't just aesthetic. Engineers needed to keep traffic moving beneath the bridge during construction, which meant building the structure in phases. 4 arches would support the westbound lanes first. Once traffic shifted, the remaining 2 arches would carry the eastbound side. Structurally, the spans ranged from roughly 300 to 650 feet, with the tallest arch reaching more than 330 feet into the air, comparable to a 25 to 30-story building. All 6 arches converged at a single massive center pier, with each one carrying different forces and requiring custom calculations. Symbolically, the arches were meant to resemble a fountain, 6 streams rising and falling together, representing Miami as a place where cultures, communities, and commerce intersect. Functionally, the new layout promised a 50% increase in traffic capacity, adding 3 lanes in each direction and relieving decades of congestion. But ambition has a price. Why this bridge cost so much? By the time the full I-395 reconstruction scope was finalized, the price tag had climbed to $866 million, with more than $550 million tied directly to the corridor and signature bridge. Compared to conventional Florida highway bridges, the cost difference was staggering. Traditional segmental concrete bridges often rely on standardized components produced in bulk. Miami's signature bridge did the opposite. Of the 345 precast concrete segments used in the arches, most were unique. Each piece weighed around 90 tons and had to be custom designed, custom cast, and precisely installed. Location compounded the problem. Construction takes place directly above two of Miami's busiest roads, which means most work happens at night. Night construction slows progress, increases labor costs, and leaves almost no room for error. Add to that Miami's hurricane season, which routinely shuts down operations, and supply chain disruptions during the COVID-19 pandemic that caused months-long delays for specialized components. What began as a bold design slowly turned into a logistical and financial grind. The ground beneath Miami that changed the plan. Even before the arches could rise, engineers ran into a problem that nearly stopped the project cold: the ground itself. Miami's subsurface conditions, soft soils layered over limestone bedrock, could not safely support the bridge's massive loads using Florida's standard-driven concrete piles. For more than 50 years, Florida Department of Transportation had relied on this method for highway bridges. But for this structure, it simply wasn't enough. Engineers proposed using auger cast piles, a technique that involves drilling deep into the ground and pumping high-strength concrete as the drill is withdrawn, creating a continuous, reinforced foundation. The method produces stronger piles with better load distribution. There was just one catch. Florida Department of Transportation had effectively banned the technique decades earlier after a contractor failure on an unrelated project. Approving it would mean reversing a half-century-old institutional rule. After extensive review and evidence from thousands of successful auger cast installations across South Florida, Florida Department of Transportation agreed, cautiously. The bridge would become the first Florida Department of Transportation highway project to use the method. More than 2,000 auger cast piles, each 3 feet wide and drilled up to 134 feet deep, now anchor the central pier. That pier alone contains over 5,000 cubic yards of concrete and 1.7 million pounds of steel, along with embedded sensors to monitor long-term structural health. Nighttime construction with no margin for error. With the foundation complete, the most dangerous phase began: assembling the arches. Each precast segment had to be delivered by truck, lifted hundreds of feet into the air at night, and placed with millimeter-level precision above live traffic. The segments are held together by post-tensioning cables, meaning even a slight misalignment could compromise an entire arch and force crews to undo months of work. To achieve the required accuracy, teams rely on GPS positioning, laser guidance, and painfully slow installation schedules. Every lift is deliberate. Every movement is checked and rechecked. One mistake could send a 90-ton segment crashing onto active roadways below. As of late 2025, only 2 arches are fully complete, with a third nearing completion. At the current pace, the remaining arches will take years to finish. Will it be worth it in the end? Supporters argue that once complete, the bridge will finally deliver what Miami has needed for decades: smoother traffic flow, safer hurricane evacuation routes, public green space beneath the roadway, and a reconnection of neighborhoods long divided by concrete. Critics remain skeptical. Many question whether nearly $1 billion should have been spent on a highway landmark instead of expanded rail transit or broader public transportation solutions. For them, the bridge is a monument to overreach, beautiful but costly. What's undeniable is that the project has become a case study in modern infrastructure reality. Building big today is slower, riskier, and far more expensive than it once was, especially when engineering ambition collides with dense urban environments and legacy systems. Landmark or lesson? If everything goes according to plan, an increasingly risky assumption, the signature bridge will open sometime in 2029. It may become Miami's defining landmark, a visual symbol of renewal and engineering achievement. Or it may stand as a cautionary tale about what happens when vision outpaces practicality. Either way, the bridge has already secured its place in history, not just as concrete and steel, but as a reminder that in modern cities, even fixing a mile of highway can turn into a decade-long test of ambition, patience, and resolve. If you enjoyed this deep dive into one of America's most ambitious and controversial megaprojects, make sure to like and subscribe for more stories that break down the engineering, the money, and the hidden decisions shaping our cities. Your support helps this channel bring you smarter, deeper builds every week. So like and subscribe, and I'll see you in the next one.